So this lesson we're going to apply our right triangle trigonometry to some real world situations. So two of the new vocabulary words we're going to have is angle of elevation and angle of depression. An angle of elevation starts at the horizontal and goes up. So this is an angle of elevation. It's always this bottom corner of the triangle. Now an angle of depression, you have to imagine a pilot is flying and he looks down at the ground. His angle of depression is from the horizontal down. So be careful, this is not the angle inside the triangle. It's the angle outside of the triangle. And what you're going to notice is because this is horizontal and this is horizontal, those two lines are parallel. And if you think back about parallel line relationships, do you see the Z shape? The angle of depression is congruent to the angle of elevation. So if you're given an angle of depression, you can write it up here in this outside corner, or you can just put it right here, exactly in the same place where you put the angle of elevation, because they are congruent. They're alternate interior. So each one of these is a word problem that requires us to draw a picture. So it says the angle of, and you don't have to be an artist, I'm certainly not one. The angle of elevation from a sailboat to the top of a lighthouse. So let's say, see, here's my sailboat, and here's my lighthouse. So we go angle of elevation. Now because we're doing right triangle trig, you know every picture you draw is going to be a right triangle. So just start there. The angle of elevation to the top of a 121-foot tall lighthouse. So the lighthouse is 121 feet tall. That's up and down. The angle of elevation was 16 degrees. To the nearest foot, how far is the sailboat from the shore where the lighthouse is standing? So are they asking us to find this direction, or are they asking us to find this one? Well, I think they're asking us for that distance. So I look at my information just like I did before. Opposite adjacent. This is a job for tangent. Tangent 16 equals 121 over x. So from here, we grab our calculator. Remember, make sure you're in degrees. And since x is on my denominator, I'm going to do 121 divided by tangent 16. And x is about 421.977. And I think the direction said to the nearest foot. So I'll round that off to 422. Approximately 422 feet. All right, next up, this one's really important. Paige is looking up to the top of the Washington Monument at an angle of elevation of 40 degrees. Her eye level is 5 feet, and she's standing 661 feet from the base of the monument. All right, so here's what we've got to do. We know it's going to be a right triangle, and we know that Paige is standing here. Now they told us her eye level is 5 feet off the ground. So here's the ground where the Washington Monument is. She's staring at it, but she's staring at it from 5 feet above the ground. So what's going to happen is we're going to find this height right here. And once we find it, we add 5 feet because her eye level was 5 feet above the ground. So she's standing 661 feet from the base of the monument. Base of the monument is down here. So if I can just find that value of x, add 5 feet to it, that's how tall the tower is going to be. So this is 40 degrees. So I look at my information, opposite, adjacent. This is another job for tangent. So the tangent of 40 degrees equals x over 661. So in my calculator, 661 times tangent 40 is 554.645. Now remember, that's from her eye level. The question was, how tall is the monument? So we want to know from the bottom. So we've got to add that extra 5 feet. So when I add 5 to this, I get 559.6. But they did ask me to the nearest foot. So we're going to round that up to 560 feet. Because this became 559.6, which rounds up. So this is really important. When they give you these, that someone has an eye level of something, you have to add that on at the very end to the height of whatever you're trying to find. This one says, Miss Varga casts a 5-foot shadow when the sun's rays shine at an angle depression of 48 degrees. So here's the sun, and here's Miss Varga. And when the sun shines down, she casts a shadow of 5 feet. Now here's the crazy thing. A lot of people struggle with, where's the shadow? Well, when you are standing in the sun, where do you see your shadow? On the ground. So this is the 5 right here. Remember, this is a right angle because we're using right triangles. And the angle of depression, remember that one's up here, is 48 degrees. And because of alternate interior angles, it's congruent to this one. So that's 48 degrees. I'll highlight that again just to make sure you can see it. There's the Z shape that gives us our alternate interior angles. So now I'm looking at, how tall is she? Opposite, adjacent. Yet another job for tangent. Tangent of 48 degrees equals x over 5. And you plug it into your calculator. 5 tangent 48. 5.553 is approximately her height. They didn't say we had to express it in feet and inches. We could, but they didn't say we had to. Next up, when the sun's angle of elevation is 57 degrees. I don't know how sun has an angle of elevation of 57 degrees, but remember what we learned? The angle of elevation is congruent to the angle of depression. We just put 57 degrees in this corner. The building casts a shadow 21 meters long. Please, 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 the shadow's on the ground. Don't put the shadow up here. The shadow's 21 meters long. How high is the building? Or how tall is the building? All right, here's my angle. Opposite, adjacent. This is a job for tangent. Tangent's busy today. Tangent 57 equals x over 21. So 21 times tangent 57 is 32.337 meters. That's how tall the building is. And one more. The angle of elevation from a ship to the top of a lighthouse. We've drawn this picture already, haven't we? Ship, lighthouse. And there's our right triangle. Angle of elevation is 3 degrees. If the ship is 1,000 meters from the lighthouse. So when they tell you it's 1,000 meters from the lighthouse, are we assuming that's this distance on the horizontal, or are we going all the way up the hypotenuse to the top of the lighthouse? I think they mean the horizontal distance. And then how tall is the lighthouse? Opposite adjacent, tangent of 3 degrees equals x over 1,000. So here we go. 1,000 times tangent 3 is 52.408. 52.408. That's about 5 stories tall. Oh, it's meters, so it's taller than that. So there you go. So those are just some applications of our trig. Remember SOHCAHTOA, sine, cosine, tangent. And the new vocabulary today was angle of elevation and angle of depression.